Hi, my name is Morgan Haynes. I'm the Operations Assistant at Criterium-Lalancette Engineers, a local building inspection company. I'm here with my colleague Ryan Cassidy, a certified radon measurement provider with the American Association of Radon Scientists and Technologists National Radon Proficiency Program. The EPA has designated January as National Radon Action Month, so Ryan and I thought this would be the perfect opportunity to come in here today to talk about radon gas with you all. So we have a radon PowerPoint we're going to go over with you and then summarize it all with some questions and answers at the end. So radon gas, what is it? How does it enter your home? How to test, fix, and save a life? Well, for starters, radon is the #1 cause of lung cancer in non-smokers. Radon is a naturally occurring radioactive gas. It is invisible, odorless, and tasteless. It comes from the natural decay of uranium in the soil. Uranium is found everywhere in the earth, in the rocks, soil, clay, and sand, and is especially prevalent in rocky areas and around granite. Because uranium is formed in pockets instead of veins, radon is site-specific. So this means that one house could have elevated radon levels and the house next door might not. Radon is measured in picocuries per liter. This unit of measure is named in honor of French scientists Pierre and Marie Curie, who were famous in the late 1800s for their work with radiation. The EPA has set the action level for radon at 4 picocuries per liter. So at that level and above, the EPA says that it needs to be lowered. So radon is the #1 cause of lung cancer in non-smokers. With cigarette smokers, the risk of radon-related lung cancer is exponential. The EPA estimates radon is responsible for 21,000 lung cancer deaths per year. Because of extensive worldwide studies of thousands of miners over 50 years, we know that miners exposed to high levels of radon gas have a greater risk of developing lung cancer. But how was the danger of radon exposure in homes discovered? Well, in 1984, inadvertently by Stanley Watrous. He worked at a nuclear power plant in Pennsylvania, and he started setting off the radiation alarms when he was coming to work. But he was setting them off when he was entering the plant, not leaving the plant. So they realized that he was the source of the radiation and he was picking it up from somewhere outside. After a little detective work, they tested his house for radon, and the radon level came back at 2,700 picocuries per liter. Remember, the action level is 4 picocuries per liter. So that's the equivalent of smoking about 135 packs of cigarettes a day. That's the damage that was occurring in his lungs by living there every day. So because of this event, the national radon safety standards were established, and Stanley since went on to become a radon mitigator and installed radon mitigation systems in over 350 buildings in the 90s. This map shows the potential for elevated indoor radon levels based on geographical location. Keep in mind that it should not be used to determine whether or not to test your home for radon, as radon is very site-specific. Approximately 1 in 15 houses nationwide has a radon problem. If you look over near the east coast of this map, you can see the red line sort of running south down from Pennsylvania. That is called the Redding Prong. That is a geological formation which contains unusually high radon concentrations, and of course Stanley Watrous' house was right on the Redding Prong there. So in Vermont, there is a 1 in 8 chance that homes could have elevated radon levels. In 2017, we conducted 552 radon tests in Vermont and New Hampshire. The highest radon result we recorded in Vermont was in Ludlow a couple years ago. The result was 388 picocuries per liter. Now keep in mind that this is the average over the testing period. During the test, there were hourly spikes of over 500 picocuries per liter. So now that we know a little bit more about radon, let's learn about the science behind how it causes lung cancer. It's actually not the gas itself, but the decay products. So uranium is naturally found in the ground all around us, especially in rocky areas and around granite. And when uranium decays, it produces radon gas. When radon gas decays, it turns into polonium. Now, polonium is actually a solid, but it can still float in the air. So polonium is floating around in the air, attaching to dust particles and other surfaces, and when you inhale those dust particles, they stick inside in your lung tissue. And when the polonium is decaying inside your lungs, it releases alpha radiation. And this has the same effect of a bowling ball being thrown through wet tissue paper when it strikes your fragile lung tissue. Now, this repeated damage causes physical and chemical damage to your DNA, which can lead to lung cancer. Now, how does radon enter your home? Basically, anywhere the home is touching the ground, radon has the potential to enter. So, cracks in concrete slabs, pores and cracks in concrete blocks, exposed soil, sump pumps, crawl spaces, drains, mortar joints, pipe penetrations, and even in your well water. A couple of other factors that affect the way radon enters the building are stack effect and energy efficiency. So with the stack effect, basically hot air rises and leaks out of the top of the house, and makeup air is drawn in, which is including soil gases containing radon. So the stack effect can increase the amount of radon that is entering your home. Now, with so many homeowners increasing their home's energy efficiency, while this can be great on your wallet, it actually traps more radon in the house by creating a tighter building envelope. So radon levels naturally fluctuate constantly and are affected by things like the radon source strength, pathways in soil, building ventilation, weather events such as rain, wind, frost, storms, flooding, earthquakes, the temperature and the humidity, the time of day, the time of season. For example, radon levels are typically higher during the winter time because the house is closed up and the warm air inside the house increases stack effect. Well water supply and also construction in or around the home can also affect the way radon enters the building. So far, we've learned what radon gas is, how it causes lung cancer, and how it gets into our homes. Now, let's learn how we can test for it. You should test for radon if you have never tested your home before, if you are selling your home, if you're purchasing a new home, if it's been 2 or more years since your last radon test, if you've done recent renovations, if there has been flooding in the area or an earthquake since your last test, or if you start using a lower level in your home more regularly. So there are 2 different types of radon tests. There is a short-term test, which typically runs for about 48 hours. This type of test is most popular in real estate transactions because you do get your results very quickly. Another duration of test would be a long-term test, and that runs for 3 months to 1 year. That type of test is more ideal for homeowners because the test does run under normal living conditions. And you also have 2 types of radon testing devices. A passive device requires no power, whereas an active device does require a power source such as a battery or plugged into an outlet. So an example of a passive radon device would be charcoal canisters. Now those would be used for a short-term test for 48 hours. Another passive device is an alpha track, and that is a long-term testing device. An example of an active testing device would be a continuous radon monitor. And this is the type of test that we typically use during a real estate transaction because it gives us hourly data. So because short-term tests only run for a couple of days, they are considered a snapshot in time. It's important to control the environment as much as possible, and this is called closed house conditions. Ideally, we like to have these in place 12 hours prior to testing. So you want to make sure all the windows and external doors for the entire building are closed. However, normal exit and entry is fine. But moving day would not be considered normal exit and entry. Contractors coming and going would not be considered normal either. You also want to make sure the flue dampers are closed, so during the wintertime you would not be able to have a fire burning in an open fireplace. In the warmer months, you can use an air conditioner, but it does need to be set to recycling indoor air. And during the wintertime for vacant homes, we do ask that the heat be maintained at approximately 55 degrees. Now, a lot of people are always curious, where are you going to place the radon monitor during our test? Well, for a real estate transaction, the radon device would be placed in the lowest level of the house that could potentially be used by the buyer as a den, play area, exercise area, or workshop. Now, if we are doing a radon test for a homeowner, we would place the testing device on the lowest, most frequently occupied level of the home. Now, for long-term radon tests, the radon device sits undisturbed for 3 months to 1 year. It runs under normal living conditions, so you don't need to worry about keeping your windows closed for 3 months. The data is collected over a longer period of time, so you do get a more accurate idea of the radon average over the long term. Okay, so you did a radon test and it came back showing elevated levels of radon. How do you fix it? Well, with a radon mitigation system. So the EPA says that a mitigation system should be installed if the radon in air result is 4 picocuries per liter or above. A properly installed mitigation system can reduce radon levels to 2 picocuries per liter or lower. A cost for fixing a home ranges anywhere from $800 to $2,400. This does vary depending on the size and design of the house and the radon entry point. So you can see here this little diagram shows the basic layout of a general radon mitigation system. It's essentially a series of pipes and a fan that pull the radon out from underneath the house and vent it above the roof. Your first step when looking to install a radon mitigation system is you do want to hire a certified radon mitigator. You don't just want to hire a contractor or a plumber. You really want somebody who has been trained in installing radon mitigation systems. Once your radon mitigation system has been installed, you do want to do another radon test to make sure the system is functioning properly, and then continue to test your home every 1 to 3 years to ensure the efficacy of the system and ensure the radon levels are remaining low. Of course, with any home system, there is a little bit of maintenance required. You will have to replace the fan occasionally, filter cleaning. There are some vents and gauges to be monitored, and the annual cost of running the fan to your electric bill is about $100 annually. Now, we have been seeing a new trend in construction where contractors are actually building passive radon mitigation systems into homes while they are building the house. This is a very cost-effective option. It runs approximately $350 to $500. Basically, the passive system is roughed in and it can be activated should a radon problem be found later in the home. Another way that radon can enter your home is through the well water. Every well has some radon in the water. Now, the main risk with radon in the water is actually breathing the gas when it is released from the water. There is only a small chance of stomach or kidney cancer from ingesting radon in the water over the course of your lifetime. 10,000 picocuries per liter in the water equals 1 picocurie per liter in the air. So you can sort of have a general understanding there. If there's a lot of radon in the water, that can really affect your radon in air levels. So I know I just bombarded you with a lot of information on radon, and I hope that if you take one thing away today, it's that you will test your home for radon gas and tell your friends and family what you've learned. It's very easy to test for radon. The state of Vermont actually gives away free long-term test kits. You can just Google radon and the Vermont Department of Health, and that should take you right to the page where you can order your free test kit. You could also purchase a test kit through a certified lab like AccuStar or a local hardware store. Or you could also search for a certified radon measurement provider on the ARST NERP website. So that's www.aarst-nrpp.com. And that stands for the American Association of Radon Scientists and Technologists National Radon Proficiency Program. And that is actually the program that my colleague Ryan Cassidy is a certified radon measurement provider through. I would like to send this over to him now. I have a couple questions for Ryan. Ryan, in your professional opinion, what is the most common misconception people have regarding radon?
Yeah, so people often tell me, I have an old house, it's very drafty, there's no way that the radon levels can be high in there. Or they, on the other side, they might say, my house is very new, only a few years old, I highly doubt that the radon is going to be high. The truth is, with old houses, even if they're very drafty, those drafts can actually create a vacuum effect that can increase the levels of radon in the house. And then with newer houses, since radon is a gas, it can come through, it takes the path of least resistance. It can come through a small hairline crack, invisible to the naked eye, and enter the house. Radon is site-specific, so the only way to tell if your levels are low is to test.
Okay, great. So if I'm buying a house and I'm having it tested for radon, how do I know that the test isn't being tampered with?
Well, this would depend on how, who is administrating the test and what type of device is used. For example, charcoal canisters, the passive device, is just as accurate as a continuous radon monitor, which is an active device that we have on the table here, but it doesn't have, doesn't record the same amount of data as a continuous radon monitor does. So the Radolink AirCat that we use has several tamper-resistant features in it. It has a tilt sensor that will trip if somebody, say, tries to move the monitor to another level or even outside. It also records alongside it. It records the radon levels every hour. It also records the barometric pressure, the temperature, humidity, and when we upload the data to a certified lab, they analyze it and they can tell if the windows were open or the flue dampers were open during a portion of the test. So that's pretty nice. So basically, if you're running your own test at home, follow the protocols and the instructions to make sure you get a valid test, or you follow the instructions from a certified measurement provider that you may hire. And here at Criterium-Lalancette, we go to great lengths to notify all parties involved of the protocols for the testing to make sure that our clients get a valid test.
Oh, that's great. Great information. So if you had one important message you could leave us today about radon, what would that be?
So January is Radon Awareness Month. So basically, you have a silent killer in your home potentially. So what I would like to say is, test, fix, and you can save a life.
Great. Thank you, Ryan.
Thank you.